the only way to become proficient at it. But if you're behind on things, I want you to put your main effort into keeping current with what we're doing right now. And then if you go back and fill in any homework you missed or any problems you skipped, that's awesome. But I'm not going to take grades for that. So we'll still have assessment grades, but I'm not taking any other homework grades. So I'm just trusting you guys that you're going to continue to do the practice because you need to. Like, not for a grade, not for some punitive thing, not for a discovery day, but for you, in your brain, you need to practice the math. That makes sense? So this could totally flop, and I could have math 3 teachers next year very mad at me, but we're going to try this. So circles and more, right? Everything, well, not everything, but a lot of things are circles. So here's the 2 main sections of this chapter. We start talking about how we graph circles, and then we talk about proofs with circles involving angles and shapes inside of them, and arcs and chords. And
I was going to start doing that on the homework.
So, this stuff is not the worst. What you need is a piece of graph paper and a compass, which I will make things a little bit easier for us. So if you guys want to pass these around or whatever, pass the collection plate.
I need to start take first pick.
And set an origin point in the middle of your graph paper. And then we're going to make a circle with a radius of 10. Hopefully, if you can fit that on your paper. You got graph paper? Oh, gotta be graph paper. I put more stacks out because it came to my attention that we were running low. So I'd replenish the supply.
You have more.
Oh. So draw your center point, draw your edge point. We need to make a circle with diameter, or radius 10, diameter 20. Now, in the standard Math 2 classes in high school, we would pull up a digital utility, but I think we're just going to do that together to try to get through this kind of quickly and then do some homework problems together if possible. So then, once you draw your circle, I'm going to give you plenty of time. I'm just giving you all the directions from the get-go. The broad question it asks first is not being expected to be answered right away, but there is something that all of the points on the circle have in common. And if it doesn't come right to your head, you'll have a facepalm moment in a minute.
They all have
the same distance.
Yeah, all has the same distance from the center point. Be careful. All equidistant from, right now, the origin. Right, because the origin is the center of our circle. So every point on the graph of that circle is going to have the same distance away from 10. So that's something, or same distance away from the origin. That distance is 10. Interesting. So look at the points where x is 6. I'm going to give you a minute. Find your circles, or put your circles on your paper.
Wait, does that mean that the y is 3?
You just said find your points.
But like, also 3 is that?
Why would that be? What do you mean?
Because it's equidistant from the center, and if it's 10 away from the center, then if x is at 6, then it means that.
So you want to find the points where x is 6. So if I throw a line up here, if you pulled up a Desmos utility, now you'd have to know how to get this graph to happen. Desmos has already done this for me, but I'm not going to show you the formula at first. So we have 2 points where x is 6. We see a 6, 8, and a 6, negative 8. Interesting. Then asks us about, what about when x is 3? Okay. So let's play with this when x is 3. Gross. No, it's asking like what are the y values? Like you on your graph paper are in a way trying to approximate it, because now if you were working the utility could do it for you. But yeah, when it's asking you when x is 3, how do we find the y value in a way? So in the utility, it just, blah. 9.539, whatever, or negative. But how if we didn't have that given to us? How could we figure that out? Easy?
Well, when you make a right triangle for that, you already know that the distance is going to be 10 because the circle has a radius of 10. So we already know that's 10. And if we know the other side, the one along the x-axis, yeah, that's 3. So we can just use Pythagorean theorem.
Ah, Pythagorean theorem. Because we can make a right triangle with any of this. Right? We talked about unit circle a little bit. We talked in trig how we can always make right triangles. Because we know that if we drop a vertical, connect with a horizontal, we get that right angle. We can do trig. So we get 100 equals 9 plus y squared, which really then leads us to 91 equals y squared. So we could more specifically say that y is positive or negative options of radical 91. Because the same thing would happen on the bottom side. Okay. Now I'm curious what the air practice had you look at for the equation of a circle problem.
I think they said they gave you a circle and then they put a center and they said find or write the equation of the circle.
Okay.
That was
They were
the
like-
first we don't know.
Oh, there's another problem. It was like transform something onto this, and then it was like something. That was just like correct.
So this point was nice though, right? It was 6-8. Is there anything else nice that you could immediately? We know that that's 6-8. There were like nice intersection points on the circle. Do you think?
Yes, you said 8-6.
When he's like behind there raising his hand, I feel bad when you just blurt it out because he's like putting a lot of effort in. But yeah, 8-6, right? Right here. How'd you know that immediately? Like, how did you know that had to be? Well, okay, we can tell. But let's say we didn't have the grid lines or anything. It's a dilation of a 3-4-5. And we know that if it can stand up or it can lay down, I mean, either way, that right triangle has to be true. Okay. We know all those distances connecting are 10. So we still need the equation of a circle. For this circle, based on what you guys set up here, like, what if I had some weird x value like 9? How do I find my y value? Pythagorean theorem. Okay. Why does that work for this circle?
Because it's a diagonal line.
Okay.
You can always make a right triangle.
We can always make a right triangle. We've made diagonal lines. We know the distance of.
You know, 2 side lines are.
Well, not necessarily 2 side lines, but we know. Well,
It's from
yeah,
the origin.
yeah. If we count the hypotenuse. Okay. So Mandy picked some random point, right? So like I picked x is 9, but Mandy just picked some point and doesn't know either of them. Yeah, sorry. I don't know why brain got me. So what you're saying is the Pythagorean theorem always works, and the hypotenuse is always. Well, let's be more general. Let's start trying to think in general.
Radius. What was the radius?
So the hypotenuse is always the radius, and the legs are always x and y coordinates, right?
Yeah.
For this circle, because it's centered at the origin.
So if we try to write an equation, does it mean that we just like generalize it? So it'd be like radius squared equals x squared plus y squared? Is that like Python?
And it looks pretty good to me. I mean, when we're centered at the origin, you guys keep saying that's going to hold true, right? It's always a right triangle, always perpendicular, the x and the y. Okay. I like it. I think that's a good idea. Until.
So right.
Until. Oh, wait, I'm one problem ahead of you. So, well, I'm sorry. To make another circle, you can either make it inside or in a different place. We want radius of 4 units. Where are the compasses? What are they stolen back there?
There we go.
Now I make my D4, not my diameter, but my radius. Man, do we have any nice intersection points? 0, 4, okay.
4,
And 4, 0, and negative 4, 0, and
Well, there's the 3, 4, 5. Right?
3, 4,
Wait,
5.
never mind, not that. That was I was thinking wrong. I'm a smart.
This is so visually pleasing, bro. That you see they drew a circle.
But you didn't draw the
That looks perfect.
So we've got our circle of 4. Right? No real nice intersection points necessarily.
Well, that's 0.
Huh?
You're pointing that one. Where?
Never mind.
I mean,
It
when
looks
zoomed
fine.
out,
I
yeah,
know, it
when
looks
zoomed
fine
out,
like
that
that.
looks really
Yeah.
close.
Yeah, I thought that was one, and I was like,
Weird. Okay. So that one's kind of annoying. The next one moves on, like the next question moves on to say, what if it's x squared plus y squared equals 36? What would that circle look like? How do you know? Okay. So the square root, so what we're now hypothesizing is the constant, well, I don't know if I need to formalize it that much, but if we have like our Pythagorean theorem set up, then our radius is just the square root of the value on time. So wait, what about d then?
that's not a circle. It's a dot. What do we have dot?
Is the dot a circle?
No, but it's not a thing. Cause it's
Okay, so it's just any dot?
No, this is not even a dot. It's just nothing.
So you're saying I can't do that? I can't make x squared plus y squared equals 0?
Well, I mean, squared is 0, but it'll be 0.
So it's a dot
The origin?
at the origin. Okay.
Is that a circle?
No,
Probably no.
but so it's a point, but specifically a point at the origin.
Well, the point is a circle because if you look close enough, the point is a circle.
Well, no, the point is just round. But I like your argument. But so the reason that I'm shutting that down immediately is I don't want you to think. I'm not arguing that it's not round. The point is round. I agree. But I don't want you to think that it's a circle, because circle has to have a distance inside of it. It has to have a radius. It has to have points on the circle equidistant from the center. So there's too many other requirements. But you're right. It's round. Points are round. So then, the whole until. So what if the circle's center isn't at the origin?
It's still not really super funky. You just have to treat it.
Then don't you just
Right,
like
right.
find
You
the
find
center
it
back to the
difficult.
center?
So
Find the.
work your way to D.
So
Should
we
we
draw
actually
that
don't
out.
work your way to D.
I just don't want to draw that out. That seems so strange.
So we are centered at 3, 1. I'm going to pull it up on the graphing utility. 3. Forget it. Yeah. Do it on your paper. Quit telling me how to make my life easier. No, thank you. It depends on how they set up the utility, whether it will let me manually override.
Wait, is that the
This
circle?
A and B aren't working with each other here. It's just moving where the center is. So that's why it lets you plug it in. And then, what's the diameter, or what's the radius 5?
Yeah.
So my D value needs to be like.
Yeah, just the
So our question becomes, does x squared plus y squared equal to the radius squared work now? Crap.
But you can just subtract the coordinates of n from those two.
X minus 3 squared.
What?
Point P. Is it just delta y squared or delta n?
Hold on, Ryan's got a really good idea.
That brings it back down to the order.
So start over again. Let's make sure everyone heard everything.
Okay, so you do x minus 3 squared, and then y minus 1 squared, and that brings it back down to the order.
Oh, wait, I think that was like the question on the.
So Ryan is saying, if I want to move my, so out here on my circle, like what I have up, I need to get my screen straightened around. What I have up on the TV, not that. I just switched. This point 8.1. If I want to shift things back to the origin, as if my circle had started there, my x value would need to lose 3 of what it has. So that my x would actually turn into like 5 to match my radius. And my y value needs to lose whatever it has off the origin, so we would bump it down by 1. Okay. I think we're on the right track. And then that would be equal to, okay, still your radius squared. I'll be careful. Were you just joking with that 6? Okay. Just making sure you weren't like actually trying to give an answer. So then can we start to make some kind of general form here? Like if the radius is 1 and we have the center at 2, 7.
Is there any way to like write it in shorthand?
The general form. According to R. I mean, according to C, center. Probably.
Good afternoon, Nathan Neighbors. Please come to the office. Nathan Neighbors, please come to the office.
Like
Thank you.
and then there's another n. That's just them being weird.
Oh, okay. This is probably pushing for. If it's a U without a tail, it means union of like 2 sets, like put things together.
Okay.
So the union of 2 groups is like, say the union of boys and girls in the Math 2 class. That would end up with everybody in the Math 2 class. But the intersection, the upside down U, always think of it as an in for intersection. The intersection of boys in Math 2 and girls in Math 2 would be an empty set, because there is no overlap. So U is union, put the sets together, N kind of is intersect. What do the 2 groups have in common?
Would that just be like
I just was trying to use a really easy example. But if you do like the union of like desserts and
bread?
yeah, desserts and breads, and maybe at your dinner there's like breads that are not dessert, but then there are also dessert breads. So the union would include all of them. The intersection would only be the dessert pieces that are made of bread. Okay. Jenny, do you have a hypothesis for one?
Oh my god, I just have a question.
Yeah.
So when we do the radius squared, do we can we solve 5 squared, can we put 25?
Oh yeah. Yep. So here, now some people like to write it as 5 squared. Some people like to write it, go ahead and put 25. That's up to you. So for 1 then, we're going to hypothesize this would maybe be
Quantity of y squared equals 1.
ooh. Circle for which 5, 0 and negative 5, 0 are endpoints of the diameter.
Number 2.
Oh, okay. Sorry, I go across. They go down.
Well, it's numbers. Numbers never fail.
They can fail.
No, they
Never
can't.
lie.
Lie.
So what do we get from 2?
X minus 3
The
squared
quantity of x
minus
minus
3 squared plus the quantity of y minus 3 squared equals 4. This is fun.
Especially now that you know how to do it.
Yeah.
Wouldn't it just be that the radius for C3, wouldn't that just mean that it would just be 5 because it's the endpoints of the diameter?
So what's my equation?
I don't know, I was just thinking out loud.
X squared plus y squared equals 25.
Oh, yeah.
Because then your center just has to be the origin, right? Because if your diameter runs from negative 5 to positive 5,
10.
your diameter is 10, your center point has to be the center, the origin. Ooh, yeah, now, because it's counterintuitive, because this is negative 2, positive 1, it's x plus 2 to move that origin back where it needs to go, or move the center back to the origin, squared. Y minus 1, because it needs to bump down to get back to the origin, and then equal to? Can we make a general form of this if I tell you just like a vertex of a parabola?
Yeah.
We, in all branches of mathematics, for some reason have chosen HK to be the x and y coordinates of our important reference point. In parabolas, that's the vertex. In circles, it's the center. So whereas graphing form of a parabola was x minus h squared plus k, right, that was for your parabola. What are we going to have for our circle?
X minus h squared plus y minus k squared equals radius squared.
And that is the equation for any circle. Now, once you start to get really good at this stuff, you can get really creative. So Desmos, one thing that I want to encourage you guys to do is check out the competitions that Desmos has.
What's our competition?
Can I earn $100 and buy purple spoons?
Oh,
Wow.
wow.
Oh, this is cool.
They draw things with
What is that?
You draw things by graphing.
No, can we,
So the lights on the front, well,
Those are just circles, yeah.
there's your graphs.
oh my god.
Oh gosh.
Yeah, it's in theory it's pretty easy because like the horizontal one, I think it's easy.
The grill,
I think it's easy, but it's
so
not.
you can turn the graph on and off. But guys, it's the same thing, just shifted, different plate, right? I want this to happen there, and then again there, and then again there. But really, it's half a circle up there, half a circle down there, like
How did I know?
this gets really fun.
Can we see
Can
how
we see
it's
the
sort of
that?
Rick.
Rick.
No, Rick.
No, I want to see the ballerina.
What ballerina?
There's a ballerina.
Oh, gee. It's a lot, but it's good.
The eyes have circles involved in them. They also have oblong circles. So all of these are domain restrictions, right? So when you make this graph and you want it to only behave like that in a certain region, you gotta restrict the
It
domain.
seems very time consuming, but it seems fun.
Like the button, there's one.
Yeah, you gotta be pretty
Yeah,
smart.
like the violin.
There's a ballerina. There's a
Or-
ballerina. Can I see the ballerina?
Actually, this is not that complex. Well, okay, it looks really complex because the graphs they had to make. But like this is all one graph, right? That long line. This you can zoom into where the points are.
Yeah.
Yeah, I mean there's like flatter parts of your leg and then curved parts down.
There's a drum set. There's a drum set.
Oh, yeah.
Turn
Very
No, I do this.
complex.
So you guys, and you can turn the graph on and off. So they turn the graph off here. You guys can check these out at your leisure. They're pretty sweet. American Gothic.
That one was taking a while.
Awesome.
So I encourage you to play with these. And this is why you create an account in Desmos, and you can just log in with your Google, but it's so you can save projects.
Oh, wow. I know.
Yeah.
So-
I just feel like food.
Sketch these equations. I want you guys to get a head start, but I'm going to show you what this looks like when you do it in Desmos. Which, by the way, I was going to show you guys, if you just Google equation of a circle, first thing that pops up from Purple Math. Purple Math is really good, but their website seems a little basic. But it's just straightforward. They didn't make it like, frills and whatever. But yeah, it's real easy to find basic math information. Google is pretty trustworthy with having sorted through the good stuff. Apparently I misspelled something. But yeah, x minus h, y minus k. So when I go into Desmos, well actually the first one is y equals a. What will happen if I stop at x minus 2 squared? So right now I've got x plus 2, and then I've got x minus 2, and now I'm going to hit squared, right? That's just the equation of a parabola. What the equation of a circle has done is it's taken the equation of a parabola, now involved the y value interacting with it. Sorry, plus 2 and then plus 3.
This is off, I don't like it.
And notice, this still can't do anything. This right now means gibberish. Some input value and some output value are getting added together and like stuff happening with them. This doesn't mean anything until you relate it to a constant. So this has to know what sum it's trying for. As soon as I tell it that, it knows what we're doing. And as I change that, I can change what we have. So one fun thing is concentric circles. Right, so as you start to get playing with things,
No, I put it at negative 2 times.
You're right.
Yeah, I did take the
Take your L.
I've been taking
so we can do like cool, and this is where people start to like, wait, I could make this into a, and then you just get really creative. Nobody ever starts those creative art things by knowing what to do. You start by playing with it, and then you say, wait, what if I restrict the domain of this?
Rainbow.
As you've said 4 times, but that's not what we're doing right now. So, if you get into the creative art stuff, just start playing with it, start throwing functions in, then start restricting things.
You should do a class on this. For enter.
Yeah.
Mark.
I've been told I had to do board games again. Because I didn't do it last
Nobody's
year.
gonna do.
Didn't
I'm
last
gonna
year
do
in
board
circles.
games.
I do
That was
board
interesting
games.
last year.
I didn't have fun doing
I just had
board
no shit. You know, just.
I don't know if I can do a whole week on stuff.
I want to do cooking. If you do Mark again.
Well, this would be like a modification of Mark.
No, we are.
No,
Yeah,
because
that's
no,
just
because then they're
after-
doing eighth graders who haven't done it, and then filling the rest of it out to seventh graders.
All right, well, that's a debate in my head now. But, so the intersection points, I have way too many circles up here. You should end up with -2, 0, and -5, -3. If you graph them correctly manually on your paper.
-5 and -3. Yes.
Wait, for the first one?
It's a little off, but
Just
visually.
And
that's how
-2,
they're
0, right?
Wait, y equals x plus 2. Is that one?
That's what the other line is.
That was your
So
first
that's
one.
the
I did that wrong.
Yes.
So,
Oh, well, that's still good though. Not gonna be circle.
Wow, I don't think so.
now this is a basic question because you guys are advanced.
Oh.
But how do we know that there's no more points of intersection? Like, how are we certain that that's it?
Because there are none other
That's so wrong.
closed circle.
Okay, and what do we
Even
know
if
about
the
that?
line goes on, the closed circle will stay closed, and it's very limited.
Okay, so we're going to make a rule. When given two functions, one linear, one circular.
Can only be 2 circles.
Or one.
Hmm.
Give a tangent.
Only.
Ooh, so if we have one point of
I was off on a
intersection,
tangent.
we went off on a tangent.
Yeah, are you proud of me now?
So, if you shift your line, eventually we can find that tangent point, right, where it only intersects once. So again, we could play with this and say, okay, well, what if I raise my, okay, maybe, too much, and maybe, okay, close, and we can just play with it till we figure it out. Now, we're not doing tangent points today, but that's where we're headed to, is understanding tangent points and chords, arcs, all that stuff. So by the way, back when this was what we wanted it to be, hold up, this, from here to here, is a chord. From here to here on the blue is an arc, okay?
Yeah.
Is it a major chord or a minor chord?
Minor chords
Okay.
are always good.
Alright, you guys want to do some problems together?
No.
Okay. Have a good day.
That's it.
Nah, I mean, we have like 5, we can't leave yet. But yeah, that's
I'll
it.
just do homework, because
So where we're headed tomorrow then?
Sweaty.